Hello and welcome again to my Physical Science online video lecture supplement series. Today's video is a post-quiz review. This one is for our Kinematics and Motion quiz, which is the second quiz for this term. Let's go ahead and open up an item analysis and see how you guys did on this quiz. Alright, so this is the quiz 2 item analysis. Looks like on average you guys are spending about half of the allowed time on the quiz. The average score for this one was only a 73.1, so that's down a little bit from quiz number 1. Nevertheless, that's actually not a bad score. That is a B, basically. And let's see what questions we've missed. There's a few questions that only 4, 5, or 6, or 9 people had. There's 22 people actually taking it. So looks like the main ones that people had some difficulty with are exercise 20, the key terms, and matching number 16 question for terminal velocity, and then a multiple choice question. And then last of all, another multiple choice question. I think what I'll do is maybe work through these first 3 of these that were most frequently missed. Seems like I left comments in the for most people who had trouble with multiple choice number 8. So let's go ahead and do these 3. So the first question that I want to look at is this EXE20 question. That would stand for exercise even 20. So it's the exercise 20 from your textbook. And the question basically is about the race car going around a circular level track whose diameter is 1 kilometer. And the car has a constant speed 90 kilometers per hour. And we want to know what's the car's centripetal acceleration in meters per second squared. Alright, so we're going to label these things. This right here is the centripetal acceleration. I'm going to label A sub c. This one right here is the speed. I'm going to label V. This right here is the diameter, which is D. But notice that D is also equal to twice the radius. Now, the reason why I say that is because the equation that you have for centripetal acceleration says that the centripetal acceleration, AC, is equal to the speed squared divided by the radius. So this thing right here is the diameter. That's twice the radius. That means that the radius is 1/2 of the diameter. So that's 1/2 of 1.00 kilometers. So the radius is actually 0.500 kilometers. Alright, now the next thing is that we want the car's acceleration in meters per second squared. So let's go ahead and plug these things in and see what we get out before doing anything else. A centripetal is v squared, so that would be 90.0 kilometers per hour. We got to square that. And then we're going to divide by the radius, which is 0.050 kilometers. Now, notice this point. I had to convert from diameter to radius. This was probably the most common error that people made on this test. Certainly it's the most common error for this question. It may have been the most common on the test. In close running was picking only one of the 2 answers for terminal velocity. In any case, with that said, let's plug these guys into our calculator and see what answer we get. So what you have to do is put in the 90, and then you square it, and then you divide that by 0.500. What you get is 16,200. So the centripetal acceleration is 16,200. 16,200 what? Well, we have kilometers squared per hour squared, that's squaring these top units, divided by kilometers. So 1 kilometer and the squared part of the other kilometer are going to be going away. So the problem is that it wants it in meters per second squared. So if we want to put it in meters per second squared, we're going to have to do a unit conversion. So the unit conversion process basically says that the centripetal acceleration is 16,200. I'm going to go ahead and just put the kilometers here, and I'm going to put per hour squared. So I got to convert the kilometers into meters. So there is 1,000 meters per kilometer. So this will get rid of the kilometers, and 1,000 times 16,200 is 16,200,000. So a centripetal now is 16,200,000 meters per hour squared. So now we got to convert hours into seconds. So there are in 1 hour there is 60 minutes, and then in each 1 minute there are 60 seconds. And if you notice, this hours is squared, so all of this has to be squared because we have to do this twice, once for each of these hours. So by the way, 60 times 60 is 3,600. So you have 1 hour is equal to 3,600 seconds, and you got to square that. So let's take our 16,200. We'll go ahead and multiply by the 1,000 there to get it into meters. Then we've got to divide by 3,600. And we have to square that 3,600. What we end up with is 1.25. So the centripetal acceleration is 1.25 meters per second squared. So how should you answer this question? As you know, when you actually are taking the quiz, you're faced with a box like this that you enter your number into. Let's draw that box a little more neatly. I guess I can't draw a box very well. Anyway, here's your box. You put into the box 1.25, and that's it. You submit that. You could think of it as if it said that the answer says the car's centripetal acceleration will be box meters per second squared. That's basically the form that your answer is taking. So your answer basically says the car's centripetal acceleration is this many meters per second squared. So again, all you do is you put 1.25 into the box and you hit enter. Now, I said this last week in the video. The reason why I'm saying it again this week is because a lot of people continue to put in 1.25 space meters per second squared. So this is the correct way to enter your answer when it asks for an answer in units of whatever. Please pay attention and don't make this mistake next time. Next most frequently missed question was this one. Question KTM16 mod. That basically means that this is a key terms and matching question. It's the 16th of the key terms, and it's modified slightly. By the way, all of the key terms and matching questions are going to be modified slightly simply because they look something like this. I'm going to basically pull up what the book looks like from my view in WebAssign. So ebook, we'll open up the book, and it's going to take a little bit to load. We're in chapter 2 in this case, and I want the key terms. I'm going to go ahead and zoom in just a bit so that we can actually see them. So this is what the key terms and matching would look like. So number 16, that was the terminal velocity. If I was going to not modify it, I would give you options A through R. So that's why all key terms are modified on my quizzes. With that said, you have to be careful, because when you look at this, you can see that most of these questions, most of these options may or may not be the same options that you have in the book. So here are all the options that you're given to match this with in the book. And in the book, when you do this, the correct answer for terminal velocity is given. It is, in fact, zero acceleration in free fall. That's the answer given for terminal velocity. And that is part of, but not all of, the correct answer. I think, in fact, that you may notice that these choices, only this one actually matches up with a choice given here in the book. Zero acceleration in free fall is choice A here. Looking through all the other choices, none of these other choices really match up with choices that were on this quiz. So maybe you were attentive enough to notice that, maybe you weren't. So what are the other options? Well, this is terminal velocity. Terminal velocity involves zero acceleration in free fall. That means that the object has no acceleration. It is moving at a constant speed. It is moving in a constant direction. That is what constant acceleration means. Falling down with a constant positive downward acceleration, obviously if there's zero acceleration, then it cannot be a constant positive acceleration. So we eliminate that one. Motion solely under the influence of gravity. That one gets eliminated because it's kind of a maybe poor wording on the book's choice, because it says that it's zero acceleration in free fall. Free fall usually means that the only thing working on it is the gravitational acceleration, that is, its gravity. Here's free fall. If you look up what the answer is here, you can look through here until you find one. This is the free fall acceleration, but free fall means motion solely under the influence of gravity. I hope the publisher doesn't mind that I'm giving away a few of their answers. They do, after all, publish all of this in the very back of the book. I'll show you that in a minute in case you've missed it. Actually, I think the online version doesn't have this. But in the back of the book, they give you all the answers to the key terms and matching. So I hope they forgive me for sort of giving a few answers out here. In any case, it is kind of a weird wording to say zero acceleration free fall if free fall is only motion under the influence of gravity. There is a little bit of contradiction in their terms. Nevertheless, I noticed that nobody put that incorrect answer. So good job, guys, on spotting the incorrect one there. Most people spotted this as incorrect. Most people spotted this incorrect. The big problem was that most people did not spot that this one is correct. falling downward with a constant velocity. Well, zero acceleration is change in velocity. Technically it's change in velocity per unit time, but it is a change in velocity. That's what makes us have acceleration. So if the acceleration is zero, that means there is no change in the velocity. So falling downward with a constant velocity matches with this definition. So that was the thing that a lot of people missed, was that there was the second correct answer. This answer is correct with a little bit of reflection on what the meaning of zero acceleration is. So that's what fouled a lot of people up, although if you look, you can see that quite a few people also got this one correct. So let's look at the next question. Which of the following is always true about the magnitude of displacement? Now, I need to sort of underline this word always because that's the key phrase in this question. And I changed this. It's MC3 mod, so this is multiple choice number 3 modified. If we open up our book again, we go to the multiple choice. We can scroll down to number 3. And here is what it says for multiple choice number 3. I'm going to zoom in a bit because I don't want to sort of overshare this textbook. Multiple choice number 3 basically says, which of the following is always true about the magnitude of a displacement? Your options are A, it is greater than the distance traveled, B, it is equal to the distance traveled, C, it is less than the distance traveled, or D, it is less than or equal to the distance traveled. Now, if you look in the back of the book at the answer is D. It is less than or equal to the distance traveled. That implies that A, B, and C are actually all wrong. If this one is right, these ones are wrong because this one is not the same as all of the above. It is not even the same as A and B. If I was to read these options aloud as answers to this question, they would read basically the magnitude of displacement is always greater than the distance traveled. The magnitude of displacement is always equal to the distance traveled. The magnitude of the displacement is always less than the distance traveled. The magnitude of the displacement is always less than or equal to the distance traveled. Now notice that when you read it this way, and this is how it is clearly intended to be read based on what the answer is, that means that A, B, C, and D are mutually exclusive answers. It cannot be always equal to and always less than the distance traveled. It can be always less than or equal to the distance traveled, but it cannot be always less than and equal to the distance traveled. The reason why I bring that up is because that was sort of a point of confusion for a lot of people in answering this. First of all, notice that I added a none of the above option, and I swapped out option D, it is less than or equal to. For this other option, it is greater than or equal to. So if you read this one carefully, you'll notice that this is not the same thing as what the book has. So you shouldn't choose this. The correct answer is it is always less than or equal to. And this is a point of confusion because a lot of people, what happened was they picked both this and this. By a lot, I mean maybe 4 or 5. And of those, one person actually emailed to explain his reasoning, which is fine. You don't have to explain your reasoning, and I don't want to be totally inundated with emails explaining reasoning. You're welcome to do that if you want, but basically he explained that what he meant was he selected these two because he thought that the combination of answers was the correct answer. The issue here is that, generally speaking, when I write one of these quizzes, if I have multiple possible answers, the intention is that each answer is standalone. So if you select two different answers, you are saying that both are true without reference to the other. So if you select this and this, you're saying that this is true and you're saying this is true at the same time, and basically that's mutually exclusive. You cannot at the same time be equal to the distance traveled. The magnitude of the displacement cannot at the same time be equal to distance traveled and less than distance traveled. It's one or the other. So if you select multiple, you're basically saying this and this, not this or this. So because we're still pretty early in the term, and that is a legitimate point of confusion, what I did was I went back through and I credited people who selected both together under the assumption that that you basically had the same reasoning as this person did. I'm not going to do that in future quizzes. In future quizzes, now that I've made this video, I expect you to recognize that unless it states otherwise, each answer is standalone, and if you select multiple, you're saying that all of these are true, not as in it is one or the other, but as in they are both true, and they are both true without reference to the other. Okay, so in this case, the answer was none of the above because the correct answer is not actually listed. The correct answer should be magnitude of displacement is always less than or equal to distance traveled. So that's all that I was going to cover in this video. I'm already kind of a little long on time, I think. But I hope that you found this video helpful, and hopefully the next set of quizzes will be a little more smooth for you. For those of you who kind of got confused on the wording of this question or on what I meant, I hope that this helps clarify that. In the meantime, thanks for watching, and good luck on the next one.